Today's notes, we're just going to review what we did yesterday briefly with the common log towards the end of the notes, and then finish up with what's called the change of base formula, which is a shortcut for evaluating things that have different bases that when we try and solve we can't figure out. And so let's take a look again at number 1. Solve for x. 7.2 to the x equals 80. So the idea was I want to try and get these to be like bases, but I don't know how. So what we did is we took the log of both sides. And remember, again, the purpose to taking the log of both sides is it will enable me to use the power property backwards and get x out of the exponent position. So the next line would read x log 7.2 equals log 80. And then finally, to get x by itself, we're just going to divide by log 7.2. So log 80 divided by log 7.2. That in the calculator will come out to be 2.22. So hopefully after checking last night's homework, you saw that you were able to do them all right in the calculator. Number 2, similar again, just with some extra operations. I can't get 9 and 31 to be like bases, so I'm going to take the log of both sides. Then I'm going to take the exponent out of that exponent position and put it in front as a coefficient. And as you probably noticed yesterday, I like to do my division first. So I'm going to leave the x plus 1 divided by 2 and divide by log 9. And then I just have to figure out how to solve for x. So I'm going to multiply by 2 to get rid of that fraction. X plus 1 equals that fraction, log 31 over log 9, times 2. And then the last part will subtract 1. So I'm going to squeeze that in up here. X equals my calculator ready form, log 31 divided by log 9. That quantity times 2, and then I'm going to take that answer and subtract 1. That may be a good one to practice in the calculator, but you should get 2.13. From there, I turned these problems into not solving, but to evaluating, and we'll look at a shortcut in a second for these, but the idea is when I'm evaluating, I want to figure out what it's equal to, so I can introduce an equals x, just like we've been doing, and I can convert to exponential form because it looks like a type 1 equation. So base to my exponent equals my argument, 5 to the x equals 40. And you're actually going to notice that this is the exact problem that we did yesterday as a solve problem, where I took the log of both sides, which got the x out in front, x log 5 equals log 40, and quick division, x equals log 40 divided by log 5. Which came out to be 2.29. And this one might look familiar too. If I add in an x here, log 37 equals x. This is common log, so base 10. 10 to the exponent equals my argument, so 10 to the x equals 37. And again, we couldn't get 10 and 37 to be like bases, so we took the log of both sides, brought the x out in front, and got x log 10 equals log 37, and we divided. Log 37 divided by log 10, which came out to be 1.57. So what you're going to notice here is our original problem said log base 5 of 40, and our answer was log 40 over log 5. This one said log base 10 of 37, and our answer was log 37 over log 10. So you might start to see a pattern develop. That's what we're going to do in this number 5. We're going to develop that formula so we can use a shortcut for evaluating. So just like the ones above, I'm going to introduce an x here to figure out what this is coming out to be. Converting to exponential form, it's base to my exponent equals my argument. So b to the x equals n. I can't get b and n to be like bases, so I'm going to take the log of both sides to get the x out of the exponent position, giving me x log b equals log n, and then I'm going to divide by log b. So we get log n divided by log b. And so what you're going to notice is log n was the argument, over log b was the base. So the shortcut is it's the log of the argument, or the number, over the logarithm of the base. So let's write that out as a official formula. Log base b of n equals log of n over log of b. And again, this is a shortcut we'll be able to use for evaluating problems. And I'll use it down in the final 3 examples. So if I'm trying to evaluate log base 3 of 17, this is my argument, this is my base. It'll be log of the argument over log of the base. Log 17 divided by log 3, which in the calculator would be 2.58. Number 6, remember this is understood common log, base 10, log of the argument divided by log of the base. So log 0.217 over log 10, and that'll be negative 0.66. And last but not least, not overly difficult, but the 15 in front just says let's do 15 minus whatever we get. Again, I'm evaluating this log of the argument, log 10.3 over log of the base, log of half. I'm going to put 0.5 just for ease of typing it into the calculator. So in the calculator, we'll be doing 15 minus that. You might want to put that in a parenthesis or do this first and then 15 minus your answer, and we will get 18.36. So your homework will be a little bit of this change of base formula. You can use the shortcut unless you want to actually introduce an x and solve and do it the long way, and then some review of our log properties. Please ask each other for help or ask the teacher for any questions that you have, and I'll be able to help you when I return next week.